First order of business, could somebody who's got more patience than me try to focus the projector a little bit? Second order of business, I need a minutes taker. Would anybody like to volunteer? It would be a big help. And you'll get my undying gratitude, which I usually can pay in beer or sometimes scotch. Nobody wants to volunteer. I will call on some of my favorites. Wes, you take great minutes. Thank you. Okay, third, we need a jabber scribe. Would somebody please agree to own reading the comments in jabber? Thank you. Gory's going to do that. Blue sheets, are they going around? They're not on the desk anymore. Okay. Okay. What time is it? All right, it's time to get started. My name is Aaron Falk. This is the Transport Services Working Group. If that's not the group that you're interested in, you can go back to your email now and tune in a couple hours. This should look familiar. This is an IETF activity. Anything that you say here is covered by the note well. I encourage you to understand it. Here's today's agenda. I made a minor change in the ordering from a couple hours ago. We're going to talk for a while about what's going on with the draft. We'll have a couple of short talks of folks who have applications in their view of what they would ask for from the network, the kind of abstractions that they would like to see exposed. And this is to, I think, inform the discussion that we have in how we boil out the stuff in the first draft. And then at the end of the meeting, we're going to talk about the matrix, which is really sort of the distillation of what are the features of the transport protocols that we have in the draft, and have a couple of different views of how you could do that matrix. Gory's going to talk about the thinking that went into what's in the current draft, and it's been expanded a little bit since the last publication. Michael's done something similar to this as part of some research work, and Dave Thaler, you may recall the last meeting, said that he had a matrix which was similar, and he's extracted from that some insights that to feed into this discussion. So, agenda bash. Anybody have any comments or anything you want to change on the agenda? Yes, Brian. Okay. But otherwise, draft it is nice. All right. We'll see at the end of the session whether it needs to be changed or not. Okay. It doesn't actually say that you're going to be the one doing the badgering. I will ask nicely. Please respond. Right. Very well. Okay, so I have one slide of it left in for administrivia. This is the schedule that is in our charter. If you're familiar with the charter, you know that this working group is chartered to produce 3 documents. The first one is a set of abstractions based on the existing IETF transport protocols to document some terminology for how we talk about what kinds of behaviors those protocols can make available to applications that sit on top of them. And that's the document that we're talking about today. We had said that we were going to have it done by June. As the working group chair, I can realistically say that we're not going to be done by June, so we're a bit behind on that. But I think we are making good progress. There's a couple of empty sections that need some work, and you'll hear more about the remaining work from Brian. Maybe that we're just one IETF behind. And that's really all I want to say about this slide. So, returning to the agenda, and hand this over to Brian. Do you want to drive, or would you like me to drive? Yeah, I'd like you to drive. Come on up. There's a pink box on the floor you're supposed to stand in.
Right. I didn't really think about that.
Generally, I think this is a really great idea to have a little pink box on the floor that you can stand in, so that the people who are so actually, where is the camera? The camera's here and it's pointing the other direction.
Yeah, the camera doesn't point to me.
Ah, okay, cool. So the pink box is really just dangerous.
Look in one place. Sorry, hold on a second. I need to say go.
So yeah, we're basically just going to go through the status of the TAPS transports document. This is TAPS. We're in Dallas. Today is Monday. Look at the overview of where we are. So the charter says basically for this item we're going to define a set of transport services identifying the service provided by existing IETF protocols and congestion control mechanisms as a starting point. The working group will consider services used between two endpoints. And if I recall, this was a charter compromise to be able to get some traction without spinning our wheels on multicast and multipoint and anycast and all of the other things that can complicate this when you're dealing with other than just unicast point-to-point services. And the abstract kind of follows the charter pretty well. Document describes services providing existing IETF protocols. I mean, we took the language directly out of the charter. Designed to help application network stack programmers to inform the work of the IETF TAPS working groups. The main thing that we're trying to do here is we're trying to catalog what we already know about the protocols that we already have and split them up in a way that they can give us an insight into how we should split these up so that we can do the work that we want to do here in TAPS, which is then be able to compose these things back together. So where we are in 03 is we took the terminology. There was a big long discussion in Honolulu, which I unfortunately missed. I mean, I was in the Java room, and people were actually standing the pink boxes, so I could see what was going on. That actually worked pretty well. And we fixed the terminology to where we agreed after Honolulu. So transport services are made up of features. That on the other side we have transport protocols, which are made up of components. And then a transport service instance is a given configuration of a given protocol to implement a transport service. Right? So a transport service is an abstract description of a set of things that a transport protocol can do for you, and then the instance is the instantiation of that. So in 03 we enhanced sections 3.1 and 3.6 on TCP and DCCP, and we have new text from Michael, thank you Michael, on SCTP, and from Kevin, thank you Kevin, on UDP. The components, so I went through and I basically took a look at all of the components sections that we have in the 03 rev of the document. This is before we have RTP. I will ask Varun nicely when he'll have that text later. No HTTP, WebSockets, or TLS yet. And this is the list we came up with. I'm not going to spend too much time on this because we're going to go into grids later, the possible grids that we'll use to sort of do the decomposition. But this is our starting point from the things that we have right now. So things like unicast, unidirectional, bidirectional, service coding, port multiplexing, different ways of doing. When we look at how we've tried to capture these things, sort of reliability and ordering seem not to necessarily be separable. Streaming seems not to be separable from reliability and ordering. So we can't really talk about taking these things as just dimensions of transport and separating them completely. There's some interplay between these components in a way that it's not just a completely orthogonal space. Oh yeah, and then we have more of them because I couldn't fit them all on one slide. Segmentation, flow control, congestion control, very important. And then the way that integrity protection versus checksums are called out. So a lot of these things are also on continua. So the status of 04, which is the present working copy, is we've got pretty much for each transport protocol section, we're following the same structure, and that seems to be working pretty well. So we'll sort of continue putting together the sections for the additional transport protocols based on the template that's there, and we'll do that in the last slide. We have additional protocol contributions in progress, yes, for RTP, so Varun Singh, and then for sections 3.9 and 3.10, we have, so HTTP and WebSockets, Dragana Damjanovic, who I've never met before, but I guess she's here in Dallas. Yeah. Hi. Thank you. And then Salvatore Loretto also volunteered to add some text on the WebSocket side of things. We basically have protocol contributors for every section except for multipath TCP, and then TLS and DTLS, which are not really, you can't really call them transports, but they have components which would be components of a unified transport stack that didn't have transport layer security bolted on as a layer on top. So who here knows something about MPTCP? Who here knows something about MPTCP and would like to write section 3.2? Thank you, Miria.
Didn't someone who's not here now volunteer already for this? We already have somebody, yeah.
Ah, okay, yeah, okay,
Not
so,
me.
yeah, sorry, yeah. Simone, from Simula. Yeah, okay, I forgot that in the slide. Yeah, so move this up, stick Simone's name on it.
Marcelo here.
Marcelo, for 3.8.
No, I'm not volunteering myself. I'm volunteering to find someone who actually writes that down.
You're volunteering to find someone for section 3.8?
For multipath TCP.
For multipath TCP. Oh, we already have someone for multipath TCP.
I mean, all I'm saying is if you need someone,
Okay.
I can get you someone who actually does that.
No, so we actually already, so this is...
I just wanted you to ask me, then I can say no.
Oh, Bob, would you like to volunteer for?
No.
All right. Still, no, we don't have anyone for section 3.8, correct, Miria? This is, I haven't heard anything from, so Colin, thank you for volunteering. At this point, we're just volunteering people who are standing, so find a seat quickly. So we can do this two ways. I can ask nicely, and then I can turn it over to Aaron, and I can't be responsible for what Aaron does. He's the chair. He has superpowers. So who here knows something about how TLS and DTLS work? Kevin. Who else? Will you take an action item to at least figure out who's going to write this if you don't do it yourself? I mean, you can also just go ahead and do it yourself. That would be great. Okay, so we'll write Kevin's name down next to 3.8. We have Simone's down for 3.2. If there's something that you have to say about one of the additional existing sections, please contribute. Actually, just take that and put it out on the list is the right way to do that.
Just want to inject the chair's comment here that I'm not going to change the agenda wording.
Okay. So here's the next steps. This is me being optimistic that we can be not an entire IETF behind, but only a half IETF behind on this. If we can get initial text for the transport protocol descriptions in the next few weeks, I don't expect any text this week, obviously, because I'm realistic. We can run 2 additional revisions relatively quickly. Some list discussion harmonizing protocol descriptions in revision 6, and then extracting features and building a table in section 4, which we're going to talk about later. I think we can do 4 more revisions of this document and, looking at it very, very optimistically, declare victory before Prague. That would be kind of I'm not saying in June, but hopefully in July we can be at working group last call if we can get the work done on the list, and I think that's certainly realistic.
Let me ask folks in the room, can I see a show of hands of people who are on the working group mailing list? Okay, and okay, you can put your hands down. A different question, which is show of hands of people, if we send out a fully baked draft for working group review in early June, you would commit to doing a thorough read-through and send comments to the list. Okay, now we're not going to take down your names, but in your notes for the things that you're taking home to do, please add that item, because my past experience has been one of the things that really slows down work progressing is the end game of getting people to review and comment and then look at revisions and get things finalized. And this group has got a lot of work to do, and we need to keep people's attention. This is not a super long document, so it shouldn't take you that long. It's not a big commitment of time, but this is the big value add that the IETF adds, which is having lots of people review consensus documents. So thank you.
Just for the notes for the minutes, I count on the order of 12 minutes. Okay. So that's great. That's pretty good.
Yep.
So,
more?
Yeah, one more. So, how to contribute? This is basically just the mechanics of how to get the text into the document. We pretty much have a structure of each subsection. It's split into 3 subsections. One is the protocol description, how the protocol works. 2 is the interface description, how the protocol is generally used by applications. What does the API expose versus what does not? We don't go into the API here. We go into if there are, for example, so for TCP, for NAGLE, right? If NAGLE is a thing that you can enable or disable on the application level, that's something that's in the interface description. And then the transport protocol components, which is the list of things that then feed into this table later. The root and canonical repository for all of this is github.com/brytram/taps transports. So you can edit this in Markdown and then send a pull request against it. If you're not familiar or comfortable with Markdown or GitHub, then just send us text or XML or Markdown or plain text email to the editors, and we'll get the text in.
Yeah, Karen Wilson from Ericsson. I have a question to the API and to what the scope is. Is the scope what the POSIX API supports? Is it scope what internet applications? Or, I mean, the reason I'm asking is that we have in the Ericsson Citrix applications, and we have a very granular interface of the applications. You can tune no matter which TCP option on an application level exposed at the ONM towards operators. And that's maybe a very particular case, so I just wondered, is that something that you want to have or you don't want to have it?
That's, I think, a question for the room more than me. So personally, the idea here is if there are features or components which are just non-optional, it's a part of the protocol. So SCTP, for example.
This is TCP. This was a TCP question.
Okay.
If we have standard for TCP applications for signaling purposes, if by standard we always are able to configure the RTO, min, max, whatever, is it something that you want to be have explained as something that the application, but used by applications, what do APIs expose? And a lot of applications don't tune this.
Right. So the question that we're trying to answer here is it possible to twiddle a particular knob on a particular component? Actually, Mary, you want to?
Yeah, very cool. I think, the question we want to answer at the end is like, how should the API actually look like? Not so much how much does it look at the moment. That's only like a meta question, which is useful to know to answer the final question. I'd say the thing what we try to look at the moment is how does the components look like? So what is even there to be exposed to the application, and does it make sense to expose it? So it's so we have a section in the document describing the current APIs because it's a good reference, but it's not the big focus in this document, and so I would only describe those things which are more or less standard and everybody knows about it.
So this would be one of those. So one of the goals here would be to make sure that the interface that comes out of document 3 or charter item 3 doesn't cut off things that people can do today and commonly do today with these interfaces, because then it won't get used, right? So.
And then the commonly do, what people commonly do today, that would be common POSIX API implementations.
Yeah, so the intention of this effort is not to obsolete the existing APIs, but to make it easier for people who are building applications to take advantage of new protocols when they work end-to-end, but and not have to build mechanisms that probe for whether they work and then do down select and have to do all that stuff on their own. If you've got something that's very optimized and you know that it works, or you've got existing mechanisms that you can use to confirm that it works, that won't be removed. This is trying to help, not displace that. But I think that from the point of view of an application that's using transport protocols, and you have a view on aspects of the API that are currently exposed. So this is one of the things that we're trying to surface now, is how do applications look at what these transports are doing, what kind of knobs do they want to turn, so I think that's a useful viewpoint that I think that people who are building the stuff underneath that layer don't always understand.
Yeah, I understand that the API may not end up exposing all these things. So my question was more as what information do you want to have right now to document the current status?
So,
and I could also perhaps think that this could be something that could go into an appendix, or it could even be information that is provided, and then said, well, good to know, this is so particular that we'll not include it. So, or do you don't want to know anything about it at all? Very quick response. So if you have text, if you already have text, or it's really easy for you to produce text, give it to us. We will collect the text, and if we remove it in the final version, it's gone, right? But like, if we have it, we can decide about it.
Yeah. Thank you.
So very focused on the same thing. I suspect the most useful bit to put in the APIs thing is what the common operating systems actually have as normal features. Not all the socket tops, not all the strange things that are in some versions, not all the extensions. If Karen's volunteering to write maybe even just a separate ID and we just gather all this stuff up, it would be very useful fodder for later on.
yeah.
But in this document, really, we want to keep this just to a few paragraphs to distinguish the different protocols rather than to deeply delve into what the application wants from the API.
Right.
That's my take.
So my take is that we put this section in here because when we first started looking at TCP, this was not here, right? It was like we're not talking about APIs at all, and it turns out that there are sort of knobs that are very commonly used in applications that use TCP, and you kind of can't understand how these components are used without talking about the API side as opposed to just the wire side of it. So this sort of grudgingly wedged its way in there. We don't want to talk about all of the potential API space. That's what document 3 is about. That's going to be what Michael says, yes?
Not exactly. I mean, well, as a Michael Wetzel, yes, I mean, I agree with what Aaron said, basically, that we're not deprecating the current API, so there is no point in trying to make everything survive in this one. And I also don't think that everything that current APIs provide should be in there. I think that because we have to have a guideline or some way of drawing the line of what goes in there and what doesn't. So some kind of rule or some logic that tells us, okay, that kind of thing makes sense to include, that kind of thing doesn't. So things like I mean, you're not going to let an application enable or disable SAC usage. Are you going to let an application enable or disable the usage of ECM? Are you going to, on what basis?
Don't turn around and look at Joe because he's looking kind of scary.
My point is, I think anything that can be a performance improvement with a lot of knowledge about the path can and should be implemented in the transport layer and should not be exposed to the application. And there's not a service to an application. That's what I'm saying. Yes, I did, but I mean that's the main. I think that's the main thing we need to agree on. So if we don't agree on it, okay, but I think that's the major question here, really.
I can actually not commit to writing in IV, but what I heard was that it would be at least interesting to write an email to the list saying what we expose today as configurable.
That would be extremely
SAP. And then, I mean, I'll try to do that, and if we do something else, we'll have to talk about whether we can commit to that or not.
Thank you.
Thank you.
This is Joe Hildebrand. One of the reasons why I think it's interesting to document the API points that the transport people know about, but applications people don't, is so that when the applications people say, oh, it's impossible to use that application layer, you can say, oh, at least in this operating system, here's the API that you can use in order to do this thing that nobody's ever used before. So that would be a darn handy outcome, and I would appreciate that as a part of this, and thank you for that. Secondarily, responding, I'm going to...
Be nice, Joe.
Yeah, so my preference would be if we could save the discussion of who is worthy enough to get access to certain kinds of information until much later in the process.
We're very well crafted, I commend you on that. Keith Moore, longtime applications person, former applications AD. I am very concerned about some of the things I've heard said here in the past few minutes. The sort of notion of, I understand, I sort of sympathize with the idea of hiding complexity from the applications. I would like to state as clearly as I can, applications absolutely need predictable behavior from the network. To the application, the network is everything from the API down. If you try to build an API that is smart, then you run a significant risk of making it less predictable. And there's really not a feature that anyone has implemented in an API that's not useful to some application. So the idea that you're going to pick and choose and decide which ones are things that need to be exposed to applications, I think is probably not the right tack.
Gordy, first, again, I don't think we're actually discussing, what we're discussing in this document is the protocols and the components that come in with services. So we shouldn't rat hole on the API thing. That's comes later.
We're gonna rat hole on the API thing, I think, in Buenos Aires, or...
Yeah. Thank you, Goy. It's a good point.
But we should go ahead and plan the rat holing in Buenos Aires, though, because this is a discussion that I think we have to keep having, because I think there's a middle ground. I hope there's a middle ground. I'm standing up here because I believe there's a middle ground. The middle ground might be falling out from underneath me.
The middle ground is the pink box. Okay, so let's wrap this up. Go ahead.
Yeah, I think we're right. Yeah.
Me, Philip, again. So just to my previous speaker, so you said like we need predictable performance. The transport does its very best to give predictable performance, but at the end it's a network which actually might change in performance. So we can't do anything about this in transport. I mean, we do our
Joe, is it
best.
something you can say in Buenos Aires?
But I actually wanted to say something completely different.
And that was an important distinction.
Okay. No, what I actually wanted to say is that at the moment we're talking about protocol components. So what's implemented in today's protocols? From those, and that's especially to Michael, so from those components, we might decide what actually is a feature based on the existing components that might be able to be exposed to applications, and based on the set of features, which is which is step 2.
So
figuring out what are the features, we can make a decision what actually should be exposed.
So I'll respond to one of Michael's points about in the mail that you sent out a couple of days ago, is that one of the things that was on previous slides is jumbograms for one of the transport protocols. I forget which one it was. Jumbograms are not a transport protocol component, and they're probably certainly not a feature, but telling the application being able to say how big the chunks of data it wants to send, that's totally a feature, right? So the component feature line is going to take a long time for us to talk about, and that's one of the reasons we have document 2, is so that we can take that discussion and have like a separate set of talking about the features that are going to be implemented separate from the analysis of the components. But in a lot of cases, we need to be very careful in this discussion and in the next discussion not to confuse the common implementations of a lot of these things, or jumbograms, or the ability to say I'm going to do this and just I'm going to hope that the lower layer is going to give me the service without fragmenting it, versus I'm going to declare that I'm sending 2 kilobyte chunks of data and you deal with it. We need to be very careful about that distinction, I think. And Aaron, feel free to throw me off here if I'm rattling.
Michael Westlagen, I do agree. I do think that removing things from the list now is the more dangerous thing than. So I mean,
Yep.
In case of doubt, let's make the list longer.
Yep. Agree completely.
Okay. So next is thank you, Brian, and also thank you, Mira and Goy, for editing this document.
Thank you, everyone.
So next is Michael Tux, and sorry, it's not that I haven't been paying attention to what we're doing, but I'm having trouble getting the slides. No. Data channels.
So
I guess I can start. So I'm going to talk about an API, a very concrete API, which is used by RTC, which is developed in RTC Web, which is an activity with two standards bodies involved, the IETF doing protocol work, and the W3C specifying a JavaScript API. So the protocols are not tied to this API, but it's made in a way that using this JavaScript API you can access all these features, and this is also not set in stone, so there's already another working group in the W3C working on a slightly different way of an API. But the features are the same, so it's a way of accessing information. And I'm focusing on data channels, so on a particular part of the stuff. So can you go to the second slide? To the third one, skip the outline. So the first thing is, what is WebRTC? And WebRTC is something which, from a service perspective, somehow exists already. So you have from a lot of big companies like Microsoft has Skype, and Google has Hangouts, and Apple has FaceTime, Adobe has Adobe Connect, and Cisco has WebEx. These are all solutions for communicating audio, video, and data from peer-to-peer. So you can have two computers doing a voice video call and do data exchange. They have two limitations. One is they require proprietary software, so you have to download some application or some plugin to a browser, and you can do this, and they are not interoperable. So only these 2 points are addressed by RTC Web. So the idea is to put to put a lot of software in the browser so that it can be accessed in JavaScript and in an interoperable way. So next slide. That's what I said already when I was waiting for the slides to come up. So we have two standards bodies working on that, and this is the architecture. I don't want to go into detail here, but I want you to show what kind of protocols are involved in this communication and what services are provided in which way. So you have two browsers communicating here, and they need a signaling channel, so they need a channel to exchange some meta information, and they have servers to talk to, and they have even possibly signaling between the servers, and this signaling between the servers isn't even standardized by these two standards bodies. So the browsers only need a channel to exchange signaling information, and they need some stun and turn servers to figure out what is the IP address the end nodes can be reached on, or if they can't do a direct communication, they can use a turn server, which is kind of a reflection system to communicate each other. And then you have this this error between the browsers, which is the peer-to-peer communication. This is the communication where the audio, video, and data communication really happens. The other stuff is only there to help establishing this. Next slide. And this is the protocol stack, or one protocol stack, which is used between the peers. So you run over IP, it can be IPv4 or IPv6, and then you run UDP, at least if this is possible. So you are trying to work through NATs, and if UDP is not possible, you might switch to TCP. That's why I said this is the peer-to-peer protocol stack when it's using UDP. So you're running UDP between them. Then you have turnstile I, so you have three protocols on top of UDP. One is doing figuring out what is the IP address I'm using, maybe using the reflections thing, and also doing connectivity checks, so figuring out what is working between the two peers. This is what ICE is doing. Then we have media, audio, video. This is running over SRTP. And we have DTLS, which is an encryption layer, giving you key material, which is used then to encrypt the audio, video, so giving you the key material for SRTP. So that's what you have there. And then on the right-hand side, you have not only media communication, you have also the possibility to exchange arbitrary user data. And you use the transport stack there, which is SCTP. And SCTP carries two protocols. One is a protocol establishing data channels and tearing them down. So you have some control information there being exchanged over SCTP. And the actual JavaScript objects, which is the data exchange. So these protocols are involved, and they are not exposed in the API in a way that you can access all these specific things through HTTP or whatever. You can set media channel. You can say, I want to talk to this guy, and then things happen on the ICE layer, and you don't have to deal with all the ICE details. So what are you setting up is called a peer connection. So a peer connection is the notion of the entity which is between the two peers. It provides you with a, I don't know if you would call it a service, but it provides you net traversal. So if the two communication partners are behind nets, the peer connection will make sure that you can talk using ICE standard turn. The peer connection will be encrypted. DTLS is there for doing this. SRTP is used for the media stuff, and since you run the data channel over SRTP over DTLS, you get security there. You have connectivity checks. ICE is doing continuously checking if the peer is reachable and if not reachable. Maybe another address candidate is reachable, so it can do some sort of mobility. And within a peer connection, you can have multiple media channels, and you can have multiple data channels. So you can have an audio channel, a video channel, 3 data channels, no data channel. That's possible. So it shares this way of talking to the peer, and you have a congestion control, sort of. So we have working groups working on the congestion control for the media stuff. SCTP has a congestion control. Not everything is solved there, but it's congestion control. Next slide.
Lost my mouse.
So I'm splitting the services which are accessible to the user here in a way that who is providing them. So there are some generic services which apply to data channels and media channels. And this is, as I said, security, net traversal, connectivity checks, and mobility. This is not specific to data channels. So for data channels, we look now into additional services. So the first thing is, what is a data channel? So a data channel belongs to a peer connection. As I said, a peer connection can have multiple of them, and they can be opened and closed dynamically. So once you have a peer connection, you can open up 10 data channels, tier 5 down, add another one, tier them down. So this is handled dynamically. You can have priorities, relative priorities among the data channels, and these priorities only apply within all data channels belonging to the same peer connection. So the way it is set up now is that the data channels share bandwidth, and the relative priorities give you a way of distributing this bandwidth between all data channels belonging to the same peer connection. And they are bidirectional. So that is a decision made by the working group that a data channel is bidirectional. So if you want a communication service, it's bidirectional, and also it has the same properties in both directions. So whatever property you have in the forward direction, you have the same in the backward direction. What kind of properties do we have? Next slide. We have a label. A label is something which it's in string. It can be exchanged for something. You have a protocol. It's another string telling you what kind of protocol you might be working on top of it. You have the priority. I told you already you have this priority stuff. So the priority in the forward direction is the same as the one in the backwards direction. You have preservation of message sequencing or not. That can be chosen. And you have a level of reliability. And it's the same in forward and backward direction. And what is important is you have these 5 properties, and you can select them independently. So every combination is working. You can do ordering with reliability or not, so there are no dependencies. Next slide. So I go through the services a bit in detail. So the data channel is message oriented. So you send a message and you receive a message. As a whole, message boundaries are preserved, and even more, you have a type. So you can send a WebRTC string, which is a JavaScript string, UTF-8 encoded, or you can send a binary data. And if you send a string, the peer receives a string. If you send binary, the peer receives binary. And from the binary stuff, you can send JavaScript array buffers, array buffer views, or blobs, so whatever. That was a decision done in the working group to send this, I think, because other protocols do the same. So some of these properties are similar to WebSockets. Okay? The message sequencing is basically you have two extreme options. One is the messages are delivered at the receiver side exactly in the same sequence as they are sent. This is totally ordered on a data channel. Or the other extreme, completely unordered, which means they are delivered as soon as the complete message has arrived. So once the receiver has all the fragments, if you need multiple packets on the wire or so, once it's there, it gets delivered. So these two extremes, you have to make a choice. And when you create a data channel, you say, I want this or that. Next slide.
Okay. 5 minutes, Mike.
Yep. Okay. And you have reliability, which means you can say, I want full reliability, which means all messages sent by the sender are received by the receiver. And if that's not possible because the connectivity breaks down or something else, the sender gets an error indication. Or you have limited reliability, which means the sender can say it's allowed to abandon messages, and there are two ways of abandoning a message. One is you limit the number of retransmissions. You can say, the extreme case, I sent this data, never try to retransmit it. Transmit it once, but that's it. Or you can say one retransmission or two. Or you can give a lifetime, which says, here's a dear stack, here's a packet. You have 1 second to get it to the peer. If you don't make it within 1 second, don't try on it further. Also, you have to make a choice for the whole data channel at the time you create it. Next slide. So, since we are talking about APIs here, how does this, this runs over HTTP, and how does this map to the HTTP features? Well, if you know the corresponding HTTP features, you will know, they are mapping these features. However, HTTP uses unidirectional streams. So what is done in WebRTC is bidirectional data channels. So they tie together two streams with the same stream identifier. The ordered and reliability properties are exactly available in HTTP. However, in HTTP on per message base. So you can set in a stream this message ordered, the next message unordered, the third message with this reliability. This is not possible in the WebRTC API. Every message has the same properties in the data channel and in forward and backward direction. So they are simplifying the features here. And they use stream reconfiguration for opening and closing the stuff. So that's a way of getting this feature. Okay? So this is the summary about the services available to a WebRTC user for data channels. And I split the list by which protocols are providing these features. So you have multiple protocols. You don't have access to the protocols maybe per se, but it's kind of an abstract way of providing more features than you have normally with UDP-RTC. Some way of compromise.
Thank you. Any questions?
So, Keith Moore, a comment from someone who's tried to use this. I have a client that had a need to do simultaneous video calling and running a different application in a way that the two shared a connection and shared fate. And basically, we found that we couldn't use this API to do that. There were several reasons for that, but it was actually easier and made more sense to do an IP tunnel and underneath this whole API than it was to try to use this API for our purposes. So I don't think it's sure it's nice and it's pretty, but I actually don't think it's that useful.
Well, it's used in browsers, so in a browser you can't say.
Oh yes, and all applications are based on browsers. That's part of the problem. is there's a lot bigger world out there than web browsers and JavaScript.
I know. I just say the intention of this is to run in a browser.
Okay, so that's limited to.
Yes.
Okay, thank you, Michael. Next is Marie-José.
So hi, I'm Marie-José Montpetit. I'm actually at MIT, and for those of you who are at congestion control this morning, I'm very, very passionate about video over the internet. So I was asked to look at the status of the draft to see how I would say, modern implementation of a video-based service could actually use some of the features that are in the draft already, which ones are probably needed to be added, and overall to see how people of my world could use, I would say, a better set of services and actually know more about it. So it's not very deep what I did because it's not based on a draft that I wrote. It's basically a comment. So I would like to say that I'm not going to go into details like the previous speaker, into details of a specific protocol. Next slide.
Pink box.
Stand in the pink box.
Oh, stand in the pink box. Okay. Pink box.
On TV. Now you're on TV.
What?
Now you're on TV.
Oh yeah, and it matches my hair and my lipstick. So you have to have matching stuff here. Okay, so I think one thing that people forget about what is the status of what people who develop video, how do they use the internet today? Actually, there's many ways, and a lot of these new things are something that us developers need to know. And I call it a multi-source video, but it's also a multi-source, multi-destination. So what do people do when they do that? Well, collaborative video creation. So a bunch of people are in different locations, and they suddenly work on the same video project. This idea of virtual reality and augmented reality, which essentially a lot of it is created locally. A lot of the content is created locally in the computer that's there, but a lot of it comes from the internet, especially when it's gaming. So there's a big issue there of two things that are coming from different sources that are getting to the same destination. Actually, and this is the idea also of the peer-to-peer. Like everybody talks about peer-to-peer, so I don't want to dwell on that one because when people think of multi-source, multi-destination, usually they think peer-to-peer, but there's more to it. This synchronized viewing. Probably nobody here watches what's going on in ACM Multimedia, but there's a big conference coming on media synchronization. And the idea of media synchronization is, again, we're here, we have video streaming here, and it goes all around the world. Well, is it synchronized? Are people capable of seeing the same thing at the same time? One way of finding that, if you want to have fun at one point, watch a soccer game on the internet and live. And you will see the differences between each. There's always a number of seconds. So people are actually thinking, well, that's not what they want. And then this idea of social television, when you start doing live commenting or live recommendations, while some of the video is playing. So now you have what the previous speaker was talking, that everything is a web application, and then you have that. You have something that is a web app that is talking to something that may not be. So what are the issues there? It's obviously the timing and the synchronization. What people in the industry call buffering events. It's when suddenly, because of losses or because of congestion, you see the little wheel inside your Netflix and you think that, oh my God, my life is over, and it probably is. This idea of, because my God, the game, House of Cards is going to live without me. This idea of the privacy. A lot of times people talk of privacy in terms of my private information, but when you start having these group of people that are collaborating, or these group of people are creating or viewing together, there's also an issue of the group privacy. So what happens to what are we watching together? And obviously, and I hate that stuff, so nobody should talk to me about DRM, but these things exist. And there's also local policies about distribution of content. There's things that you cannot see in a country at the same time as other. It's a mess, but these things exist. Next slide. Another thing in my world that people are, I'm actually in two worlds. I understand transport people, but I also live in some of the applications. What is my transport? So if you go and talk to people, oh, my video is real time, it runs over RTP, or my video is a download and actually it's an HTTP type thing. But for these people, that is the transport. The transport is not UDP or TCP, so they don't really recognize that when we talk transport, we're talking lower than that. And that actually is something Teja presented this morning. And that there's these two things that are happening. There's this real streaming, which is the real-time service, which is very similar to what the previous speaker was presenting. It is very, very similar to video conferencing. Well, we're lucky because on the internet right now, the only few things that are actually true streaming are live sports. The rest is actually much more the next thing, which is the adaptive download. The adaptive download, it's not real time. It actually looks real time, but actually the whole thing is usually buffered in your end device, and it plays out. But for the first one, RTP is the transport, and for the second one, it's actually HTTP. And there's a question to the group. I know that in the list of potential transports on page 19, RTP and HTTP are not considered transport. They're considered something that runs over the actual transports. But in a way, should they be transport? And I do not have the question. I have the question, but I do not have the answer. So I would say maybe it's something that we want to think about as a group. Next slide, please. So I decided that since this is the IETF, I have to have a controversial slide, and this is it. So if you want to start lining up at the mics, it is time, because... What? When you come to the IETF, you have to raise controversy. So this is my controversy. So do we need a new definition of what a reliable protocol means? For us, we all think that TCP is reliable because eventually the packets get there. But do they? And do they? And maybe sometimes they're dropped in somewhere, maybe they're not getting there. And we know that, okay, so we agree that UDP is not reliable because I was saying as someone before, if my 911 call is stuck behind a huge file, it drops. But for a lot of video, and actually some of the web sessions, neither one are reliable. And that is actually, if you talk to people who actually develop applications, when they see the little wheel going down in Netflix, for them the reliability of the protocol has gone to zero. And it actually is well known that when you see this little wheel, and the wheel runs for more than 5 or 6 seconds, 90% of the people will actually then close the window. And if you're in the business of supplying video services, you don't want that. So there's all the impactful losses, the congestion, and of course there's also the issues of the privacy and security that I was mentioning before. So if something is reliable, it should also be reliable against the NSA speaking out on what it show that you're watching. But for a lot of people, the context of reliable does not just mean the reliable delivery. It also means reliable delivery of the service that is supposed to be provided. And I'm not saying that we should change in the table on page 19 what is the checkpoints for reliability, but maybe we want to come up, and I didn't come with a better word, but maybe we need to come up with a better word to describe what we mean by bits that are actually delivered to the application. Yes?
Well, I should say, this business of variable has been going on for 4 years. And I'm not that old. Basically, what TCP's variable mean doesn't mean that you will always succeed. What it means is that it will always succeed or give up, and not do it halfway. The same way that quality of service doesn't mean that you will get more bandwidth. That means that you will get what you want or nothing. And that's not necessarily always understood, but that's really what it means.
But that's what I'm saying, is that I think maybe in the context of the draft, we want actually to explain what we mean by, like when we talk of reliability.
That might be very useful.
Yes, so you know, this is what, in the context of this service taps, this is what we mean by reliability. And people who want to have all your bits delivered to watch your movie, it's not called reliable transport, it's called something else. And I'm not disagreeing with that.
Dave Crocker, I think you raised an interesting point, and really the largest point here is the disparity that happens a great deal when different communities use the same word. That inevitably they use the word, especially when they're terms of art, they use them differently. The only suggestion I have for the particular case that you offered, and I don't think this will prove to be a general solution, but reliability really isn't the term you want, it's usability.
Probably, yeah. But usability, by the way, usability is also used in another meaning. So, you know, we can't get into...
It's a term of art in the human factors space.
Yeah.
So probably the right approach is to take the whole space that this is trying to do and try to think in terms of the audiences, which unfortunately a document like this has lots of multiple audiences, and look for words that are not terms of art and possibly even just revert to plain meaning, which is going to be a very different issue.
Yeah, okay.
Darshit Thakur, Cable Labs. So I'm just trying to understand. So how is this different from quality of service? So, I mean, especially in case of video, right? It's
well, you should know
if I want to do video over TCP, the reason I don't do it is because the video bits are only important to me for a few seconds, and if I can't deliver in those time, I might as well throw them away and get something else. But TCP doesn't give me that.
Well, I try to stay away from the word quality of service because, again, for a lot of people who develop video applications, they talk much more of quality of experience. And I don't want to go, you were talking of digging rat holes about things. Well, quality of service and quality of experience is one that I will not get into, at least not now.
David Black, been in this space recently trying to understand what quality of service might mean for the WebRTC stuff that Michael was just talking about, mostly on the audio and video side. So first, strongly agree with quality of experience, because what matters here is the user's perception of video delivery. Doesn't matter how reliably bits are getting delivered. As you pointed out, if the video won't render, the user's not happy, and the fact the network did a really good job is kind of irrelevant. Now, the answer to what does this have to do with quality of service, the last speaker almost got most of the way there. This is time sensitive. And if you think video is time sensitive, let's talk about conversational audio, which is truly unforgiving. And so there are underlying QoS requirements on what you need to deliver, and there are also now the codecs have gotten a heck of a lot better. So if I'm running a video application, the quality of experience is a combo of the network delivered quality of service with what the codec decides to send into the network, and the codec is capable of responding to network conditions by adjusting bandwidth and effectively trading experience for timeliness.
That's called engineering.
Absolutely, and this organization's middle name.
That's it. So I think what a lot of people have done to try to get into this is actually try to boot what I called UDP tunnels with perks. So you start putting everything on a UDP tunnel and you start to tweak a few things and you hope everything goes better. Do we need a better transport? But another aspect that I was thinking about this is there's all this idea that, and somebody was just mentioning, there's a lot of things that are dynamic in there. So can we make it dynamic? And the next slide is the rat hole.
So before we go to the next slide, I had a comment that I want to make, so I'm in the virtual queue here, that the goal of this exercise is to identify new dimensions, abstractions that we're not exposing that application developers want. And to me, a term like quality of service or quality of experiences is inadequate because it's not an abstraction that helps. It clarifies understanding between the two communities, sort of the providers and the consumers. And so my takeaway from this is that one of the things you're talking about here is timely delivery, and that you might want to quantify it, parameterize it in some way, because different things may require different kinds of timely delivery. But I just want to ask you whether you thought that there was something beyond that. Is there more beyond that to capture the point that you're making?
Well, I think there's the on-time delivery. There's the if it gets on time, but every other packet is corrupted, it's still not good. So there's the on-time delivery. There's the I will use the word reliable. There's the fact that the bits that are actually been delivered on time actually give that quality of experience that the user wants to have. So I think there's this idea of not only delivering in time, but delivering in quality, and again, pushing back or helping the codec that's pushing the bits into this. So again, I think there's many layers to it.
Okay, thank you.
So I want this question written from Microsoft here. One thing I see from this discussion is that tech reliability, for example. At the transport protocol level, there are two ways of engineering. You can do ARQ or you can do forward error correction. And those two ways have very different implications. Forward error correction is less efficient from a bandwidth point of view, but much more efficient from the spinning wheel point of view.
Mm-hmm.
And so having that expressed somehow by the application, as a do one rather than the other, or basically make sure to do this kind of stuff, not that kind, would be useful.
Well, wait for the next.
Okay, I'm going to cut the line off here, and then we'll let you get on to your next slide. So this is the discussion that I was hoping we would have. So this is good. So maybe we don't need a rat hole. Go ahead, Dave.
Dave Crocker. So I spent a few minutes now contemplating various terms that people were suggesting and the issue that you've raised with this. And I'm finding myself quite liking the term David Black came up with, quality of experience. QoE doesn't... I'm sorry. I still like it. I liked it. I liked it in spite of the fact that I thought David was the one who proposed it. And I like it better now. No, but it doesn't collide with any existing terms of art. It goes at the meta level of issue that you're trying to raise. And so separately you then go through the exercises of figuring out what the technical components are.
Thomas Eckert. Yeah, I think this reliability, redefining it can become quite difficult, right? I mean, we had some draft up also to explain how in video different packets might have different priorities. That's not only for video, we've seen that in other information.
No, it's me.
That's the quality of experience.
Yeah. That's operator Aaron.
Yeah, so in terms of in a single video stream, right? I mean, there are very important packets that you definitely would love to get, better reliability for, not necessarily at the expense of additional delay, but for example, better forward error correction. And then there are packets you'd be more than happy to give up, and then you look at...
You want to lose your iframes.
Yeah, exactly. And it's not only video specific. You have the same thing in, I don't know, market day transmission or so in the finance market. There are probably a lot of, IoT cases where you would have similar things in any type of, real-time traffic that periodically gets repeated. So I'm not sure if this is something that, we really have enough guts here in this working group at this point in time to try to pick up in its entirety. And any subset of that, I'm just starting to question what would be the subset of something like that.
Nope, I'm cutting it off at Matt. You guys can wait till the next slide. You have your chance.
I'm Matt Michaels. I might be accused of gaming the system, but I'd actually like to see the next slide before speaking.
The next slide is a rat hole because it is a rat hole. So you didn't sit down. That's great. So it's not. I'm sorry, it's not Buenos Aires. Well, I hope I will go because I have an uncle who lives right across from there. But so the case for the TAPS API is actually, I think, on the list, and I think also from the discussion here, application developers don't know what VCN is. They don't know what even sometimes a packet is to a certain extent, or they will not say turn it on. Well, actually, the people in my world of application, so I can see people. I told you this is the rat hole. But they do know what they want to require from the transport. If not, they could choose anything. Right? So I think, and again, this is the controversial thing, I think the idea of exposing some of the features of transport, and also not only exposing it, but I would say also querying it, could be very interesting. And if you want an example from the people who are not in this room but have done work like this, there's actually a protocol from IEEE 1905, which essentially hides the details of a MAC layer and just allows you to query what are the instantaneous conditions of the map, which is actually, it's not at the layer that we're talking about, but it actually is very useful because you don't have to worry when you develop, in that case, an internet application, or what is happening, is that power line or Ethernet that's below you. So it's just the point that I think it would be useful to have things like that, and I think we kind of agree, but it's not Buenos Aires, so I'm ready to let it go. Yes, Matt?
I think we're in complete agreement, actually. And I want to tell a story in a different way, but I think it's the same point. History is littered with stories of the form, some application designers said, these crazy transport people, they don't know what we're going to do. We're going to invent our own transport protocol. We're going to do it right. And after a couple of years of pulling their hair out, they've reinvented yet another broken, almost TCP or something. And history is littered with these stories. And to some extent, all of the arguments that have been made here are correct in some context. The problem is there's an incredible amount of complexity. And I think the answer to that is to both provide an easy menu which hides all the detail, and then also a pry the lid off, expose all the detailed ways of looking at stuff. And so if you provide, imagine this as a transport toolkit, you get insight, don't invent your own transport protocol, go pick tools out of this toolkit, and the toolkit will automatically tell you, oh, if you do this feature, you need to put in this feature. If you're going to do application flow control, you need to worry about deadlock. There's all sorts of things that are connected together that people keep on rediscovering the same mistakes. And we both need a simple way for applications to do it mostly right cheaply, and then we need a rich way for applications to dig into the details when they need to. And we need applications not to keep reinventing transport.
Okay, the line is long and time is short, so I'm going to ask people to be terse and pithy.
I'll try. Keith Moore. I totally agree with the last statement. I think there's a real challenge in, so people developing applications don't necessarily know about transport. They certainly don't know how to build one well by themselves. And they don't know how what they want to do maps onto specific features of transport protocols. And I agree with all of that. To the extent that you can help that, that's a marvelous thing. Where I have problems is, I see this line, if not any transport will do. And what I'll say is if there's a late binding between the application's request and the transport that it gets, what you get is even less predictable behavior out of the network as perceived by the application than you get if you force the applications to make specific API decisions about what features they're using, what transport protocols they're using, and so on and so forth. So the latter seems like a bad idea. We're burdening applications with all this complexity, but it actually results in more predictable behavior. And that's what that's part of what really worries me about what I hear some of the people saying here.
Joe Hildebrand, I continue to urge us to avoid sort of the label making kinds of arguments of application developers this, transport developers that. Just as we continue to move forward, I don't think that it helps us come to the engineering.
I knew people were, but it's because I picked that up from the discussions on the list, and
Yep.
I've seen a lot of that,
Yep.
and I'm agreeing with you, and so where's my engineering project here? I think there's no transport developers and application developers, there's good engineers, and if we're going to do something right, we have to work together.
I think one of the useful bits of sort of nomenclature to keep in mind is library developers who happen to be writing code in user space for other people to reuse, typically more complicated code like your SSL libraries, etc., where there's a small number of people who have the expertise to build those, and most other sane developers who reuse them rather than starting over from scratch. So I think that gets to the point the previous speaker was making about having some stuff that's quote-unquote hidden and some stuff that's made available. It's, well, the person who's writing the library has to see all the bloody guts of it, and that person will choose to up-level the parts that a more traditional application developer needs to see in order to write their application more correctly.
Jana Iyengar, I wanted to keep away from talking about transports and applications without talking about precisely what it is we're talking about. There are transport protocols, there are application protocols that we know about, and there are transport functions that we think about when I think about distributed systems. It's really important that you expose information like ECM up to any body that's handling a transport function that you traditionally consider a transport function, and it doesn't matter where in the stack it lies. So if we are talking about actually exposing through an API something that is such as ECN, for example, is something I would love to have this available in what you might consider application today, because from somebody else's point of view, they're actually using that for transport functions.
Yeah, and I think when we talk about applications, we also have to think that, we're all also application users. So there's applications that are for people watching video, and there's applications, like you said, for people who actually develop these things. So I think we have also to be very open to satisfy the needs of both worlds and of everybody. Thank you.
This is not an easy problem to solve.
No, I know. But
And
if it was easy, we wouldn't be here.
I just want to add one more thing to an earlier thing about quality of experience. I do not like the term quality of experience at all, because it's way too vague and it says nothing specific about quality of service. I think is a bad term. Quality of experience is worse.
Okay. We're going to close this session, this topic in 5 minutes. So I'd like to ask each of you.
I have 2 slides.
I know you have 2 slides, but we have a queue here. So I'd like to ask people to make a 10-second point, and please go sit down so we can.
Sit down there.
Because if it's a good point, you'll have a chance to make it again in the next section, because it's, these are the topics that keep coming up.
So I think in this group, or from my understanding, this group, one constraint to limit the red holding is that we only want to use existing mechanisms we have in protocols and potentially expose them. We don't want to add additional protocol mechanisms right at this point of time.
I hate my next slide.
So yeah, we can still have the discussion. I just wanted to make this clear. And that was the idea about the chartering, to actually get down the discussion a little bit and to get one step at a time. The other point I just got to my mind listening to the discussion is maybe, and we had discussion previously already, maybe we need 2 different kind of APIs, because in some cases an application just says, I want connectivity, I don't care which protocols underneath, I don't care if it's TCP or if it's UDP and then something in between or a whole stack. And in some cases you already know that only TCP works over this path, so you actually want to say, I want to use TCP. This is the case where you usually already have some information about the network, so you actually know something about the layer below, and maybe there's not only one API. That just came to my mind, and I wanted to have it in the minutes so we can think about this later on again.
Mary stole my point. I wanted to point out that we've ripped this entire slide apart except for the S at the end of APIs, and that S is very important. And then Joe has already made the answer to my point, and I think that that's basically where the libraries come in, right? Because the application is going to want to write to its abstraction of the network, and let us let many abstractions blossom, and then have the machinery underneath be something you can build those abstractions out of, because we're computer science, which is all every problem by adding an additional layer. But the S in that APIs, I think, is extremely important. So, thanks.
Somebody was widely reacting to this. Maybe we can talk after. Next slide. Okay, so it's too small, but this is actually the table on page 19. And so this was actually some of the suggestions. So we talked about this already. Maybe add RTP and HTTP as potential, but I want people to discuss it on the list probably. See also which one of these features that are on that whole list, or what I would say, are API ready, or actually could essentially, no, it's in the draft. I just highlighted a few things that have already something there that can be exposed. So how would we build an API based on this table? Do we need more services and application-oriented categories? Can this be a can actually do time delivery or something? And maybe that's not this table, Corey. Maybe that's another one. I was talking about this new reliability category, and we don't know. It seems now people hate quality of experience. It seems maybe we'll just call it blue, and it's going to be the blue feature. And now this is actually for the previous speaker. I was thinking maybe we want to leave room for future transports, things that may come up in the future that would have the features that a video delivery application would have. But these are just suggestions.
Okay.
Thanks. So future steps, I don't know. I'm not an author of the draft, and I can write a few things on the list, but I don't know what you guys want, and I have my last one. because these things never happen on its own, I would like to acknowledge all the people who actually have talked to me in the last few months about these things, and that's it.
Okay. Thank you, Marie-José. That sparked an energetic discussion.
That's what you want.
That's what I wanted. So, I believe you are. I don't know, let's take a look at the agenda and see. No, it's you and then Michael and then Dave. So now I need to find your slides. No. Sorry, give me 1 second here.
Well, it's fun to stand in the pink box. You can do anything when you're not on the camera, can't you? At least it's in the same room. Okay, I'm going to present some slides, I think, which are based on what we have in the current draft, and trying to figure out what tables we might put in next, and how we might populate these. This set of slides tries not to talk about APIs. It does mention the API word, but when we did the charting, we decided APIs were not going to be discussed in this working group, although we keep going back to them. It's not one of the things that we're actually on the radar immediately, and we all know where we want to be in the long term. Similarly, we're not going to talk about non-standard track transports, because again, that was something that was removed in the chartering stage. So it just talks about the things that we currently know about, and oh yeah, okay, oh yeah, that looks good. So hi, I'm Gary Fairhurst, and this is the Notewire.
This, you guys don't I apologize, but I do not know what's going on here with this projector. Is just doing really strange things to my computer. So let me try again.
Anybody get any questions so far?
No. It's wait, taps tables. Here we go. All right, I'm getting warmer, and then I see. All right. I'm sorry, Corey. Okay.
Get to here.
There we go.
Here we go. Yeah. Okay. So
I see it on my screen.
Yeah. Right. Okay. So here's a picture of. Can we go back? Yeah. There we go. Right. Okay. So. Right. I'm trying to paint a picture of where I think we're trying to go. Now, this may be right or it may be wrong, but it's my introductory slide anyway. I expect that we can define a set of transport services, and when you want to use these transport services, you can describe them in some way, so you can describe what features you want. Up there somewhere, there's an API. I know we're not allowed to define it, but it exists somewhere, and it lets us choose a transport service. So a transport service is something a little bit more concrete. It's the actual service that gives us the ability to push things across the network. The transport services are provided by a transport protocol, and then we have these functions underneath. Now, this is my quick slide to introduce where I'm at. If the terminology isn't the same as what Mira has previously presented, I refer to Mira entirely, so Mira is the holder of the terminology. So if my terminology is wrong, then it will just be corrected, so that's fine. This slide. Right, we have this wonderful diagram. This is the one from the draft. You do not have to read it. I put this in the draft because we need something to talk about. It's not complete. It's just a list of the functions or mechanisms which we see in different transport protocols. So this is clearly not the end goal of this document. This is the summary of how to compare these different transport protocols. So as we look through this, we'll see that there are different mechanisms, and the first thing that we can see is this long list is obviously not extensive. There are other things that these transport protocols do which we haven't listed. So we are never going to get to the end of this, because as soon as we start unpicking all the transport protocols, this list will grow ad infinitum. They're all different. So we're going to have to be a little bit more careful about how we distill this down. Next slide. One thing we can do is we can identify some things we hear which probably shouldn't appear on that list of services. They are not things that you need at an API level to actually know about when you call upon which transport protocol you're going to choose. Do you care about what sort of feature negotiation your transport protocol has? Probably not. What you care about is using your transport protocol, and you have certain things you want from it. Similarly, how does it support options? These are details that differ between our transports, but we don't have to go into the details of when we're exposing it to the application above. So my suggestion is these things probably are things we can compare on, but they are not things that we want to put in that services list. I'd suggest ECN support probably lies here as well, and that's maybe a little bit tricky if you're only in UDP land, but for other transports, the ECN stuff works under the hood. It's hidden. Okay. I'm not sure about RTP. I'll just confess out loud. RTP is pretty complicated. It's got a pretty large number of different use cases for different things. If we start unpacking RTP here, we're going to end up with a very big table. So we just have to be careful here when we look at what we get for RTP, that we get something that's useful to compare with. I know we have an author committed to actually giving us some text that will be useful. It will be a good input. But word of warning, if we unpick every possible thing you can do in RTP, that will also be a bit of a nightmare. Question?
Next to all this part, maybe based on the previous discussion, inspired by it, why are we saying that we can compare the features on the table, but the applications that use it don't need to know? Wouldn't somebody write an application that might want to compare on these things, and if so, why don't we remove them or have them on the table? But in this case, for whatever reason, like UDP NCAP, I think is what it says.
Yes.
On the previous last line, there might be an application that might use this knowledge for something else, like whether it needs to traverse some firewall in one direction or another, who knows what. So maybe it should be something that the API expose.
Okay, we end up with a very, very wide API if you start unpicking the details underneath here of what RTT calculation you're going to use, whether you're using smoothed RTTs, other types of RTTs, what your RTO configuration is, and similarly all the details. So what I'm really saying is, I don't know how to build that service list, but we need to compare the functions first, and then we're going to need another table where we actually start building a list of things that we think are genuinely useful to the application. Now, that might be tricky in itself to get right. Oh yeah. And it may be that you can't get it right once. Maybe one of the things that was said was the API's word. Yeah, maybe we need a top-level one, and maybe there's a whole lot of detail that the people who know what they're doing will have to call into. Good. Discussion. Jana.
Jana Iyengar, are we going to do the trimming here?
We are not doing the trimming here, but what I'm trying to assert is we should consider having two lists. We should consider having a list of things that compare our transport protocols in their behavior, in their mechanisms, and then we should build a second list of things that we think are offered by those transport protocols to the things above, the upper layer protocol.
Can you also build a filter that we can slap on top of them that says these are the transports that are actually deployed?
We could. The scope we've been given are the transports which have been specified by the IETF. We know where to put the energy when we describe those.
I mean, is that exhaustive? I understand that this is energy to be spent on protocols that are built inside the IETF, but does it have to be all the protocols that the IETF has built? Let me be more specific. As I see it, UDP and UDP Lite don't count as transports because the thing that's sitting on top of them is a real transport. DCCP, nobody's using it. So we're down to SCTP or UDP and TCP.
Yeah, except that maybe there are things that are similar to DCCP out there, and we may be reinventing one in the IETF. So from the point of view of this process, we keep this lightweight. I mean, I have no intention of flooding out the DCCP text for every possible thing we can do in DCCP. I think this should be kept short, and I think keeping it short is actually okay. If you might differ, we can talk more with.
Thinking about ECN as a specific example, and I believe this can be applied to the other things which are crossed out here as well. The reason why we discuss about ECN is because we didn't do our job very well in getting ECN running. If we would have all the fallbacks implemented in the transport and nobody has to worry about ECN anymore on the higher level, because if it's possible to use it, it will be used. If it's not possible, it will not be used. If that would be done in the transport correctly, it shouldn't appear here. But as those mechanisms are not in the transport layer, you want to give it to the higher layer to maybe decide about it. So not sure how to solve this problem now, but I think that's where the origin came from.
Yeah, and I concur, but again, like all these things, you can say just ECN and you just get a little word up with every packet you get. But there's a shed load of stuff you've got to do to make ECN work across the path, and you've got to implement the congestion feedback, and you've got to have the congestion response, and you've got to have the failover. So all these things end up with a lot of mechanics above this API if you expose them. And yeah, that may be what we end up with, I don't know. But it makes life complicated.
I'm just saying, if all those mechanics are in the transport already, then you don't have to expose it anymore. If they are not there, don't know.
Christian Wittemar from Microsoft. When I look at this table, I can't help thinking that some very important problems are missing. And
of functions of transports.
Yes, certainly. I'll give you two. One is the point that Marie-José was making, is that when you look at congestion control, for an application, congestion control has something important, which is, how do I know which packet I should send next? How do I choose? And that basically, if I'm informed about congestion control events, I'll make different choices. And so having something like that is important to feedback. The other part is, in the current debate about how to architect transports, one of the biggest issues is the interplay between transport and security. And that is not represented at all here, because all of these are transport from the 90s that have no security.
Yeah, but I immediately come back on that one, because those sections have not yet been written. If we could get people to contribute those sections, we can add them. We're looking for text contributions for the security sections.
Yeah. Didn't you volunteer?
That was Bob Briscoe that volunteered.
Hint, hint, hint. I mean, if you want to start by making a small contribution, you don't have to sign up to any of these in a big way. You can send us whatever you think is useful, and we'll work with it.
Just send us text.
Send us any text. Yes. Magnus.
Yes, Magnus Preston. I reacted to this ECN. I mean, RTP, having written the ECN for RTP spec, RTP is one case for ECN information. You need to really tie it into the higher layers, because, like you said, the congestion response, so to say, needs to happen on what's above RTP, because it's the codecs, etc., that deals with this. It's also the missing layer, so to say, with the congestion control mechanism that it's like ORMCAT is working with, that needs to be dealt with it. So that's one comment. The other thing was, I think we're actually not complete here in protocols being used in unicast, but that goes into your scoping question about not looking at the multicast, but unfortunately the multicast protocols are kind of escaped into the unicast world. So I wonder if we actually need to talk about the certain of the RMT combinations which actually might be used in some special cases on unicast transport.
Okay, interesting story. You're wondering about it. Do you want to offer text? I can try. Yeah, I mean, there's a... Oh, Brian Adamson. Just in case that was missed from the meeting notes.
Yes. I need to find out some text.
You can offer text. Okay, yeah, keep talking. That's fine. Anyone offering text can have more time. Oh, sorry, Colin.
So I guess I need to talk fast.
In a new week, it's a 20 words a minute, doesn't it?
Yeah, we should bring Echo in or something. So yeah, I'm Colin Perkins, I think. I think we perhaps have and this is perhaps just because the draft is incomplete, but I think we have a slightly restricted set of transports here, which is looking at a very traditional view of what the transport looks like. And RTP has come up a bunch of times. I think it is something that needs to go in here. And yes, I know you're going to say offer text, and I will certainly help Varun write that, although I'm not committing to writing that whole section myself. But coming back to Maria Jose's talk, I mean, that some of the application level features in protocols like RTP are quite different to the things we're talking about here. And as much as it expands this table tremendously, I think if we want to include the sort of breadth of transport features that modern applications depend upon, I do think we need to start bringing some of those in. And that could be some of the group features, it could be some of the ways of talking with middle boxes, it could be the partial reliability, it could be the timeliness, the timelines, that sort of thing. And I think some of those fit into things like partially reliable SCTP and so on as well. So I don't think it's just RTP that's easy.
Excellent. Somebody actually bit on it when I pushed back. In fact, that would be very welcome to have stuff on RTP. But let's figure out how that makes the document go.
Colin Perkins.
Doesn't work.
I'm trying here. I want to clarify something that Jana said earlier. This is what I meant by transport functions as against transport protocols. The thing that sits on top of UDP is the transport. UDP is doing a couple of things, and so it's kind of important to include many things that sit on top of UDP, because all of them have to deal with the transport functions that are not available to them anymore because they're using UDP. And so they do it in a variety of ways. RTP is one example. RMCAT is going to be doing this as well. So
one of the things about including RTP might be we get examples in this space, which would be really useful for other things to compare against. Because there are other things which pick packets from effectively a datagram socket and put things down and do it late rather than have big stream buffers in front of them. So there are things here that go on inside real applications which are done particularly over UDP, which RTP gives us a few examples of that as well.
So in the interest of time management, I think the suggestions have been made. I think we've got an author and Colin's willing to help, and so I think let's move on from this topic and try to get some other comments in. I'm not trying to cut. If you guys have other points to make, I'm just trying to. It's like, okay, we'll document RTP. Let's do it.
Is there an item on the agenda for why all this is a bad idea? Is there a time for them to discuss that?
That was 2 IETFs ago, and we had the boss.
Just found it out this morning. Sorry. I'll just keep getting up to the mic and pointing out things that you're missing.
Yeah, okay, do it on the mailing list as well. That's fine. Okay, so. I crossed some things out randomly, used some response. That was pretty cool. They're not crossed out in the draft, so we need to work on that. Next slide. Well, we need to define the other things. They were the functions that were in the transport, but we need to define something about what we call the service offered by the TAPS API, if you call it the TAPS API. So I tried with Tyler to come up with a list of 10 different things that you could offer to an application or upper layer protocol that might be things that were generic rather than tied into particular protocols. We have the APIs which are tied very much into, say, SCTP or UDP or RTP or whatever. We need more generic terms, so we need things that you can choose amongst in those more generic terms. So here's a straw man list for the very first time. We need to make this list somehow. This is the very first cut at that this will go on an email, and we can then bash this to try and work out how we compare the different functions that you can provide across this service interface. Question?
Mark Nottingham. So I'm just trying to get my head around this. These are the services provided by the transport to the application.
Service components.
Sorry, terminology, yay. And there will be eventually an API that you can say, I want this and that and that. How do you plan to account for the differences in quality or properties of different implementations? These are all abstractions, and all abstractions are leaky. So, we've just remapped HTTP onto a different mapping onto the same transport protocol, and it has vastly different properties, much less switching to something like SCTP or UDP. How will that, are you really trying to paper over those differences here, or how does that work?
Yeah, but this working group is not going to define those APIs in its current charter. So this is a structure to help us understand what these things are.
Okay, so
this is not the API definition.
Documenting what's out there. It's kind of the output.
It's documenting it, and this is trying to layer it up a little bit so you can have that discussion which you started there.
Okay.
But it is not about solving that at this time.
So we keep on saying APIs, but not now. APIs, but not now.
I'm afraid we do, and maybe we should end up with we should get Mira up here and she'd do a new terminology thing for API, so we don't have to keep calling it an API when it isn't an API. But we all know there's got to be an interface.
Right.
So we're talking about what the architectural interface might be.
Right. So full disclosure, my discomfort with this is based on painful personal experience. I spent several years working in web services in WS Star. I'm so very sorry. And that's what that effort was all about, was trying to paper over those cracks and say, pay no attention to the underlying transport. We're going to provide consistent higher level service components, like reliability, and you don't have to worry about the implementation underneath. And that turned out to be disastrous. So, and that's probably the applications folks, and I know we're not calling people applications folks, that might be the source of some of the skepticism you're seeing.
And it may be why we're not doing the API yet, if ever, but we're not doing it here.
So putting off the problem will not make the problem better or more tractable.
It may, and I'll just come back on that, because what we can do is we can define things below in the transports which can help with things like path NTU discovery and sharing state information and help with maybe your ICE and etc. So there are things there which really transport people can deal with.
So Keith Warren, I'll actually make another statement, which is adding more layers of abstraction will not make things work better either. I have a really strange feeling of deja vu about this list, because about this discussion, because about 10 years ago I was involved in something very similar. I'll repeat Mark's sort of thing about long and painful personal experience. I spent about 5 years trying to build an API that did a subset, a slightly different take on what you're trying to do. One of the things that the applications I needed to deal with had to care about path selection. They really mattered which source and destination IP addresses you use, whether you use one or more than one, what the particular characteristics of those are. You could add another 10 bullets to that slide based on things, sort of abstractions that are clustered around why does an application need to care what its endpoint addresses are. But it does, in fact. So it's just this. I mean, it's kind of like I don't blame people wanting to look into it, but it is a huge rat hole, and you should be aware of that right now.
Can we document that and move on? No. Can we? I think that's inappropriate.
Keith, are you willing to accept that you've made the point, we've heard your comments, and so that you don't need to keep making it?
Do I have to keep raising the issue of last call and the working group last call, and when it goes to ISG, and do I have to appeal it to IAB, or is it solved?
Sorry, I want to jump in there because we all have painful experience with APIs. It's really hard to get it right, but we can truly do better than what we have right now, and we just try to. I mean, why would you stop this right now? I don't understand it.
So this is Joe Hildebrand with my IAB hat on. We're interested in seeing this work progress at the point where you are now. We think there's interesting architectural things to discover by doing at least this first step and probably the second step. And we'll see if you guys can convince us. It says experimental protocol on the third step. So it's more the IESG you have to convince that last bit. But we see architectural value in at least the first two steps. So please keep working.
Thank you.
Chris Newman. So in looking at the list, the first thing that just points out to me as glaringly missing is visibility. If I'm using any sort of an API layer or library layer or to provide services to my application, the piece I really need is visibility and logging and auditing into all the knobs of the lower layer. So I want a way to say, tell me what's going on the lower layer. I need to know what protocol, I need to know all the endpoints, I need to know all those details about the lower layer, any auditing or monitoring points that are available. As an application, I should be able to get that data.
So I agree entirely, but I'm not sure that's something you can signal across and tell that you need from the start, because you need it all the time. So is there different grades of this that you wish to ask for? Or is it kind of just something that you want as a function of the whole thing?
There may be, there may very well be, particularly when it comes to monitoring, there may be things that are expensive to gather, and I may want to say, yes, I want to gather that, or no, I don't want to gather that based on performance requirements.
Okay. Well,
so that's for things like monitoring encounters and that sort of thing, diagnostic callbacks, etc.
If you can think of a simple slider knob that could describe that, then that would be a useful input. As in something that we can use architecturally to figure out how much of this you want.
I mean, I suppose, if you want it at its most coarse, it's what when you're doing a CLI, it's what manifests as a -V or -VB, -VDB switch on the CLI of, I need more information about what's going on underneath, the verbose output.
Yeah, okay, maybe we've got a scoping thing here, because we're talking about selecting the transport that you're going to use and which functions you want from that transport. This is not about how the API is constructed and what feedback you can get from the API. So that doesn't actually influence your choice of transport, does it?
Oh, absolutely.
It does, okay.
If I have monitoring requirements for my transport that a particular transport can't meet, I can't use the transport that doesn't meet those monitoring requirements.
So, for example, a transport that reported its loss rate, is that the kind of thing?
That's a good example. You have to go into specific applications, but that's exactly what I'm looking for. Sorry.
So you said you have requirements which your transport might not meet. So what you want in the API is to name those requirements, and then the transport can choose the transport to match your requirement. And then if the requirements are matched, it doesn't matter which transport you're using. You don't want to know this information anymore.
I totally disagree with that. As an application, I want to get as much information about what's going on under the hood as I possibly can. If you hide data from my application, I can't debug problems, and I won't use your layer.
But that's the API thing.
So, I am okay with the idea of maybe I have looser requirements, go ahead and pick a transport for me. Maybe that will work. I'm open-minded but skeptical. But once it's selected, I want to know what was selected and every detail about what was selected.
Okay,
but why you said for troubleshooting, or why? I mean, why do you want to know it? If it just works, it works.
No.
Can I jump in the line here and say that what we need to do is we need to write down visibility of what's going on in the transport as a requirement and move on.
Yeah, okay. And if Maria still has questions about this, that we can talk to her offline.
I just wanted to say, I mean, if it works, it's fine, right?
Yeah, but this is the internet. Things never always work. Things always break.
It's always broken. Matt Mathis, speaking as a longtime networking guy who's occasionally brushed up against browser people, if you talk to a browser person, you talk to them, start asking questions about the network, what they mean is this piece of code that you hand a URL and then magically later it hands you a file descriptor or something that was loaded into the cache. And everything is abstracted away. I have mixed feelings about that, but one of the things that is missing at that layer and is missing all the way down is idempotence, which occurs above the layer that you're talking about and is not on your list. And that's actually a problem because preserving idempotence is actually a big deal for things like fast open and doing parallel opens on different technologies. And the fact that the web doesn't understand idempotence means that we can't make use of doing certain kinds of decision strategies. And that's something that this group is the right venue to expose and tease apart. But it's actually closer to the API than we are chartered, I think. And it's not on your list for that reason, but it really needs to be there somehow.
It could go on the list in this document, perhaps. We'll put stuff into the document, and then we'll see what the working group thinks of it.
I think it's a good point. Phil, before we get started, I just wanted to, management interrupt here. I want to apologize to Michael and Welto and Dave Thaler. I think, I'm just going to make a call here. I think this discussion is probably more important than having more presentations, and so your slides are, both of your slides are posted for meeting materials here, but I think we should try to get as many voices here in the time that we have left. So go ahead, Phil.
Okay, I went to some of this stuff with a brief conversation with Dave, so if Dave feels he wants to jump in and help answer, it's okay. He's at the back of the line anyway to make a comment.
He's in the line, so
Phil Baker. So I've done security, I've done apps, I've done most parts of the stack. Now there's one thing that I was taught very early on when we were doing the web at CERN, and that was never ever tell somebody they can't do something. Never ever tell you that you understand the problem more, so much better than another person, then you can tell them that they will fail.
So you're telling us we can't do that?
No. I tell you to not listen to the people who say that you can't, because now
we accept this. So we accepted this in the BOF. So this is accepted.
Looking at the API piece.
Which API piece?
Well, one of the comments that I heard coming in was that I had another thing that I had to go to, but sorry about that. But one of the things that coming in, somebody said, well, more abstraction doesn't help. Well, actually it does. There's two ways you can look at this problem. One is to look right down in the depths, which is all you get today with the socket API, and I'm doing this thing that's so precious and special. I need all this data, so everybody else in the universe needs this data. Well, no, we don't. For my applications, I care about DNS names, I care about service names, and that is all. I don't care about IPv4, IPv6, or pidgin addresses. I don't care whether it goes over IP or DECnet or OSX. I don't care. I don't care whether it goes over UDP, TCP, or trucks. Because my applications are insensitive. So for me, a high-level API that just lets me say, I want to talk to this protocol. You give me a connection to that, and you layer in the security, you layer in all the stuff that you know how to do. That is what my application wants to do. Now, the business of mapping from the abstract to the concrete, that is what my platform does. And my platform is where I want to have all the code that's agile and can say, oh, I've got some keys that can be brought to bear, and I've got some validation, I've got a cert store. So don't reject this idea that more abstraction helps. More abstractions is the solution to this problem, really. But the key is, you want to go not just like that, you want to go way more abstract than today.
Thank you.
Hi, I'm still Colin Perkins. So I just wanted to, a couple of things. Firstly, to respond to Maria, who seems to have disappeared some. I mean, even if those comment, if things work perfectly, why do you care about the visibility of the details? Well, you care about the visibility because there are lots of applications for which you need to know how well it works perfectly, so you can prove that you're meeting your service level agreements and so on. So I think we do need this visibility into all the gory details of what the transports are doing for at least some applications. The other point, looking at the list which seems to have vanish.
You want that? Well, the list was a pretext of what we're going to send out in an email. So that was just get people to form a line at the mic.
And it worked admirably. I was surprised that some primitive upon which you could build NAT traversal wasn't a transport service. Or at least learn something about middle boxes.
This is all part of the puzzle, and it may even be part of this experimental thingy, which turns out to be phase 3 of the work, because NAT traversal is obviously something that's really important, at least for the V4 guys, and we'll look at how V6 deals with discovering ways through firewalls as we go along, I guess.
Yeah, I thought it was on the list. I thought it was the first thing on the list.
Okay.
Connectivity was the word.
Perhaps that was the intent. Yeah. Okay.
Yeah, the iTrap list.
The other thing, there seems to be some sort of assumption here that you're building an end-to-end transport protocol, and increasingly many systems have middle boxes which they wish to talk to, and middle boxes which they are talking to and maybe don't want to talk to. I don't know to what extent functions to allow interoperation with middle devices.
I think that's part of number 3, where we're just trying to figure out the transports available at this moment and what we actually have in our toolkit. I mean, it's stunning that as an IETF we've been working on this stuff for God knows how many decades, and we don't actually have anything that talks about the services, even though the Transport and Services group is one of the areas in the IETF. There's so little stuff on services we have to kind of start at the beginning. Will we get there? I hope so. Well, Brian wants to say something. Go on.
Spud buff Wednesday morning, 9 a.m. I forget the room, but it's in the agenda.
It's more than just the spud buff. It's things like the additions to protocols like RTP, which already work with middle boxes in the network. So some transports have been doing this for many, many years, and it seems to not necessarily being recognized.
Well, we will do when we get the RTP mixer text. We'll be happy to go.
But also the RTP security text, and the RTP congestion control text, and so on. So
and one thing that I think I'm going to add or put this out on the list. I think after looking at Michael's slides, we probably want in document 1, the TAPS transports, to talk about ICE and SUN or NAT traversal as a thing that some transports do, right? So there's talking middle boxes in terms of NAT traversal, and there's talking middle boxes in terms of signaling, and the signaling stuff we're going to talk about in SPUD.
Sure, but there's also talking to middle boxes in terms of partial encryption. That part of the encryption can be decrypted by the middle box and part can't. Or there's talking to middle boxes in the case of decoupled congestion control loops where you split the congestion control halfway through the
right. And we can certainly see.
I'm going to interrupt here. We've got 4 minutes left, and I'd like to try to get a few people to speak who haven't been on the microphone yet, if there are any. No, I'm not able to get the slide up again. I've been trying. I don't know why.
Was I missing naming in there? I can't remember that I saw it in there. Yeah. So naming definitely is, I think.
Naming is something that varies between transport, or naming is something we just have to do right?
Well, the underlying problem is that there are, requirements from the industry to, as much as possible to everything that somebody has to pay for within a single round trip time, right? So basically, all these things will become, if we want to meet these requirements, glued much more together. And that way, I don't want to worry whether you want to officially call it transport protocol or something that we need to do in this work, right?
Okay. Fine.
Yeah. And the other part is, I don't think the waterfall process to do APIs at the end is working completely. I think, the amount of discussion we had about APIs is showing that. I think a compromise might be that we will have, as planned, the decisions about what APIs we are going to do at the end, but that basically the input, this is the nerd knob I want, totally unstructured, right? Just as the input into the process that we track somehow, right? Even if it's on a wiki. So the whole point is, even in the description of the transport protocols, if you're trying to describe something, you have to figure out in the first place, hey, what level of detail do I need to describe? And ultimately, it's those levels of details that go higher up into either the abstraction layer or ultimately in the APIs. So if you don't have the crazy wish list of all stupid, nerd knobs you ever wanted to exploit, right? You don't even know what levels of detail to describe.
Yeah, with hesitation that we actually have spent more time talking about the APIs, which we're not meant to be talking about in this working group, than any other topic. So we need to put that somewhere where we can keep it safe and let it mature without us stopping doing the rest of the work.
Dave Taylor, I'm going to say something similar to what you just said. I think there's a lot of angst around the notion of APIs and sort of what we're doing this for, right? What's the next thing that's going to consume it or whatever. I think, and there's vastly divergent views, I think, within the people that have been at the mic, and maybe even for one or more of the people standing behind me might be saying something similar. I think it's useful to know what another group ran into. They repeated some of the same discussion. That working group was RMT, and they were tasked with decomposing the set of services that reliable multicast protocols need. And they did that. And they had some of the same discussions, and I wasn't an active member of it, but I understand where they ended up. Where they ended up was that the thing that the decomposition of building blocks, the user of that was the person defining the transport protocol. The person was defining what the components were that was their protocol, not the application. The application had an API to choose the protocol. Each particular protocol was just a particular assembly of components, but where they ended up with, and it's just an interesting learning point to see, is this working group going to end up in the same point or someplace different? I don't know. But it's useful to know that they repeated the same discussion. What they ended up with is the application doesn't say, I want the following sets of properties. Where they ended up with is say, I want the following protocol, and each protocol has a set of properties, but the API didn't choose it at that granularity. It's just interesting that that's where that discussion ended up. And maybe there's something there for us to learn from, or at least communicate with the people that were involved with that.
I agree entirely with what David has just said. Having worked with multicast transports for ages, having that RMT framework was a great place to concentrate on the right arguments rather than just get diverted down all sorts of rabbit holes, because we could say, well, it's more like normal, it's more like, etc. And that was such a useful thing in getting the multicast stuff actually made real.
So it's 3 o'clock. We're out of time. Because our folks are at the mic, I think we should go 5 minutes early, 5 minutes late, and each of you take 60 seconds to say what you guys say, and then we will let people go get coffee so you can entertain the next working group chair for an hour.
Jana, a big plus one to what Dave just said. I was coming up to say something very similar, that having a taxonomy of different transport functions is extremely useful, because we don't have a place where we have put that yet. And having the IETF protocols identify these different functions, being able to articulate how they are offered in these different transports is extremely useful, and it's really useful for somebody who's off building a new transport, which may have some of the same functions. So it's very good to be able to look there. Although from an application point of view, you're likely to either choose one of the existing transports and say, I can't have everything, or you say, I'm going to go build a new one that has the things I need. It's very unlikely that you're going to try and have both of them.
Thanks.
I just want to make the point again, the working group is not chartered to hide information from anybody. It's actually want to expose more information than we have at the moment. However, every time somebody comes to me and says, I want this information, I just ask the question, why? Because to my experience, I know that they have a very important point, but they might ask for the wrong piece of information. I can get them even better information. So I'd really like those people who say, I need this information, I can't get it right now, please come to the list and explain which information you think you need and why you need this information, so we can actually try to make it better.
Yep, good point.
Chris Newman, I saw security on the list, which is good, but I wanted to suggest secure by default as a philosophy around the list, and how that manifests depends on various things. I mean, UTA did a BCP, which in essence is a secure by default BCP. So I wanted to suggest that principle, the secure by default, be considered throughout the process.
We'll make sure we keep on tracking security things. Thank you.
Thank you, everybody. Well, this was fun. Hey, Gabe. How'd you play buddies again on the raffle, mate? How are you? Good to see you. Yeah, I have. idea. Right. I mean, I think this whole discussion was about, hey, we've come up with these abstractions, do they make sense? And is there a gap between the way an application would think about things and the way transport expresses them? And a lot of the rat-holing was we hadn't completed the transport